All right, July 11th today. For the past week or so, maybe week and a half, I've been working on refactoring the monster spawn manager, the whole object pool I have set up. I didn't really like the way I had it before. It was working fine, but there was a lot of improvements I can do. It really just wasn't too friendly to use. The whole system I built was kind of a mess. So some of the issues, this pool size I have here would set the size for all of the monster pools, so there wasn't any variety at all. All of the monster types would have the same number of spawns, which I really didn't like. And of course, when it gets to gameplay, it really isn't fair. Like, why would there be 20 plain monsters and then 20 of the brute monsters? That just doesn't seem fair at all. Let alone 20 thief monsters, 20 of the fast monsters, so on and so forth. So there was no variety at all. The spawn points I have here were vectors, which again, fine for the beginning, but they're really unfriendly to be working with because I would have to figure out the coordinates within the world instead of placing an actor down, which I'll get to these squares in a moment. But I would have to find a point in the world, let's say right here, and figure out where that coordinate is. Really not fun. And then here I have monster classes, which would just be my blueprint classes for my monsters, which is fine on its own, right? Except there's some conflicts happening within the C++ class I built, which I will show you right now. So right here, this is where the conflict is right away. I only have it as tank right now, but imagine before you would have, it would be something like this, right? Really, the source of truth would be from this enum instead of being the arrays indexes here. And that's kind of working backwards because the source of truth should be the blueprint classes because those are the actual implementations of the zombies, not the enum here, but it's pulling from here instead. Here, we have an array of arrays, which again, is fine. This isn't a big deal. And then I just have a bunch of functions which are working well. They could be better, but nothing too bad about these functions, at least the naming and the purpose of them. Getting into the functionality, this line here, again, not too good because the enums are the source of truth instead of the actual pools. Big mistake here. So this is, again, where the pool size is being a big dictator here. So there's no variety at all for each pool size. So we have 20. It spawned 20 instances each. This isn't too bad as well. I mean, it's fine. Again, it's just the enum making the decision here, getting the spawn point, just getting a random index. This is fine. The only problem is, again, F vectors, not too fun to be working with, at least in my experience. And everything else, nothing too crazy. In my opinion, I think all of these were fine. Handle monster death. I don't have too many complaints about this one. The one issue I did have before is this death animation actually didn't exist beforehand. I would just have a flat amount. So it'll wait 3 seconds, which this wasn't even great as well because this would mess with the animation times. Some of the lengths would be shorter than 3 seconds. Some of the animation lengths would be longer. So based on the timings, monsters would just lay down there for a little bit before respawning, or their death animation wouldn't even finish in time before respawning. So this is just a little cleanup that allows it to be better. Of course, if the death sequence doesn't exist, which would be my mistake, that I forgot to import or set a death animation, then it would be set to 3 seconds. But I went through all the monsters already. They all have a death animation and it's all set in their BP class, so nothing to worry about there. So those were the big issues with the class. Good bones, but it was just really unfriendly to be working with. So there was a lot of steps that went into this refactor, lots of splitting things up. First things first, before I can even start to work on this new manager class, I needed some form of data to be driving this whole operation here. So I made a monster pool data asset, which controls everything about the monster in terms of spawning. Think of it as its config file. We have the type of monster it's supposed to be, if it's active yet, starting size, its starting cap. We have the current cap of the pool, which just keeps track of where the pool capacity is at right now, and the max cap, which is the highest number of monsters that this pool can have. Nothing can grow beyond it. And growth increments just outlines the growth of the pool. And then just to show you how I have it all set up here. So we have normal monster here for the normal monster config. 3 starting, 3 cap. So 3 will be spawned, 3 will be allowed to be active. Current cap again is 3. Maximum number of monsters we can have for this class is 6, and over time throughout the course of the game 3 more monsters will be spawned. Again, the values aren't finalized here. I'll see how it feels once I have a whole map in place. So that's the data asset portion out of the way. Here we have a structure of the actual monster pool. So the idea of this is to still have one shared pool, although there's 2 arrays, but instead of searching between one array of which zombie is dead, which zombie is alive, which one I can spawn, which one anything anything like that. Again, this is just time-space trade-off, right? I'm using more space to save myself some time here. So any monsters that are dead and they are available to be spawned, I'll throw them in the available array. Any monsters that are currently active within the game, running around trying to kill the player, they're in the active array. Just keeping track of the current cap so I don't have to pull from the data asset. Next, increment index. This is for the growth increments, just keeping track there. And then we have the basic object pool functions. Acquiring a monster, releasing a monster, and adding a new monster. Acquiring a monster, removing it from the available array, adding it to the active array, returning the monster so when it gets returned in the manager class, I can do additional setup that makes sense for the manager, that being adjusting its collision, making the monster visible, setting its health, starting its behavior tree, anything like that. Release monster, just removing it from the active queue, adding it to the available queue. Monster manager handles any sort of state in regards to the monster. Adding, just adding something new. Spawning, anything like that is going to be handled in the monster manager. Clearing, yeah, just clearing stuff. Nothing too much to go there. Okay, spawn point actors. Super simple class, just a simple actor class. I wanted to keep it simple in the first place. All it is used for, just spawn it in the world so I have something to drag around, easily set the spawn points from its location vector. The only functionality I have is in regards to its spawn. Because a previous issue I ran into, there's only one functionality here, and that's in regards to the spawning. A previous issue I ran into is that monsters, when they spawn almost identical in time, and they spawn at the same place, they collide with one another and they kind of just break. They kind of just stop working. So instead what happens now is that when a monster is spawned and it uses this spawn point actor, we'll say, hey, we can't spawn anymore, but after a short timer this can be used as a spawn point again. I've really only had this issue at the beginning of the game when all of the monsters are being spawned, and this has fixed my issue, and I'm hoping that throughout the duration of the game, if there's any timing conflicts of being spawned, this will help to resolve it and I won't have to run into that issue again. Almost there. So we have a settings file. When I was creating the new manager class, I needed some sort of reference to the data asset implementations here. I created a little settings file, and within the project settings I'm able to just set those up here, so when I go ahead and use them in the manager class I have easy access to all of these types. And then finally, here we are, the new manager class. So instead of an array of arrays, we have a map here just outlining each monster pool config to its monster pool. These are here to make the system work. They're still actors. However, once I change them to subsystems later on, I don't think I need to have a reference to these anymore. I might still need to forward declare them, but I don't need actual references to them. We have our spawn points to our actor. And here's all of the types I was just talking about that I needed a reference to. That'll be linked through the settings file. Quite a few functions now. Again, mainly just for creating the pool and growing the pool. And a few helper functions. So initialize, deinitialize, nothing I needed to do here, at least for initialize, deinitialize, just some simple cleanups. Any sort of setup I needed to get done, really only thing that's new is the settings, as well as this on hub upgrade reached, which I'll get to soon. Creating the monster pool, a couple of checks here, getting our starting size, creating the pool struct, setting its cap, spawning all the monsters that are hidden, and adding them to the pool. Spawning them hidden, we'll talk about that shortly, but we're just spawning them into the world and hiding them, marking them at position 000, just for them to be within the game, but not active in chasing the player. Create and populate pool is just a simple wrapper function. Now they're all created, now they can be activated within the game and ready to use. So this is the function that's going to be used within the game. I won't be calling create monster pool, so it'll only be this one. Setting current cap. This is mainly just a cheat manager functionality. If I ever wanted to change the current cap while the game is running, it'll just be easier for me. Just getting the count here. If there's any sort of shrinking we need to do, we're just going to remove those monsters. If the value is larger, we need to grow, then we'll just grow it. Growing the monster pool, again, a couple of checks. Getting the pool, quick check to see if we still have any growth increments left, and then just setting the new cap based on the increment and the current size and spawning the necessary monsters. Again, simple wrapper function. This is what's going to be used within the game. Activating a monster, so we're just taking a monster that's been spawned and hidden, getting a random spawn point within the world, and then doing any sort of setup we need for the monster to actually be well alive and chasing the player. This function, on hub upgrade level reached. Outside of creating the monsters and growing the monster pool size, this is the most gameplay-esque function there is here. We're just reacting to whenever the upgrade level has been increased, and we're adding some new monsters or growing the monster pool if we need to, based on whichever level it is. Spawning a hidden instance, just spawning it at 0, always spawn, and then hiding it within the world, and also setting up some delegates here for our other systems to listen to. Random spawn point, same thing as before. We're just seeing if the spawn point we have, is it a legitimate spawn point and can we spawn it, then we can return it. If not, we're gonna try again X number of times. If for some miracle it fails, which I should never have to come to that because I'll most likely have more spawn points than the max total of monsters available, so hopefully I'll never have to run into this issue. But if it does, it'll return null pointer. From spawn point, it just won't activate the monster. Handle monster death, same thing as before, just with a couple more error checks here. Nothing changed. And now that this whole thing is a subsystem, I don't have to worry about spawning it into the world. There isn't anything like that. However, the only setup I had to do was A, create all of these spawn point actors, which I'm okay with just drag and dropping it into the world, and B, this initial monster pool manager setup here. This is just here for testing. I have all of the pools spawning for now, but ideally it'll only just be the normal monster at the beginning. None of these would be here. But for now, I'm happy with it being all of these 6 monsters. It's way easier to have it within here compared to within the C++ code, so I don't have to recompile it every time or do some sort of live coding recompile. Now I can just adjust it in here, which will be super nice. So yeah, this is the whole system here. We have all of the different zombies. This, I do need to fix this spawn. I don't know what's going on with this guy. You can see now he spawns there. Yeah, they're all using their spawn points now. So that is super nice. And just for fun in games, what I'm going to do is just adjust the config. So the starting size is going to be 0. Now everything is just adjusted in the editor. There's no more of me going through C++ to make any sort of silly adjustments in terms of the pool sizes, what gets spawned, anything like that. Everything now just happens within these config files, which is amazing. So super big improvement for me. Monster system feels a lot better now, even with this improved monster spawn manager, or monster pool manager now I should say. Next steps is probably adjusting the whole behavior tree system, making it more interesting, making it a little bit more complex, adding some AI perception if I can do that too. I know there's a whole environment query system I can use as well. So those are the next things I'd like to look into. But yeah, just another day. Talk to you later.